Hi guys, welcome back to my virtual classroom. So today we have a new setup and this is my work from home setup. Now let's continue our video lecture series. Our subject is Es6 Engineering Economics and this is lecture 2. So we are still under chapter 1, Introduction to Engineering Economics. So these are the topics under chapter 1. Our lesson for today is Engineering Economics and the Design Process. Engineering Economy and the Design Process. An engineering economy study is accomplished using a structured procedure and mathematical modeling techniques. The economic results are then used in a decision situation that normally includes other engineering knowledge and input. So shown in the slide is table 1-1, the general relationship between the engineering economic analysis procedure and the engineering design process. So on the left column, we have engineering economic analysis procedure and on the right, the engineering design process. So yung step in engineering economic analysis procedure, step 1, problem recognition, definition, and evaluation. Yung activity niya na katapat niya in engineering design process is problem or need definition. Step 2, development of the feasible alternatives. Yung activity na katapat niya is problem or need formulation and evaluation and synthesis of possible solutions or alternatives. Step 3, development of the outcomes and cash flows for each alternative. Step 4, selection of criterion or criteria. And Step 5, analysis and comparison of the alternatives. Yung katumbas niyang activity is analysis, optimization, and evaluation. Yung sa Step 6, selection of the preferred alternative, the activity is specification of preferred alternative. And Step 7, performance monitoring and post-evaluation results, yung activity niya is communication. There are several feedback loops within the procedure. For example, within Step 1, information developed in evaluating the problem will be used as feedback to refine the problem definition. As another example, information from the analysis of alternatives may indicate the need to change one or more of them or to develop additional alternatives. The engineering design process may be repeated in phases to accomplish a total design effort. For example, in the first phase, a full cycle of the process may be undertaken to select a conceptual or preliminary design alternative. Then in the second phase, the activities are repeated to develop the prepared detailed design based on the selected preliminary design. Problem definition. The first step of the engineering economic analysis procedure is particularly important since it provides the basis for the rest of the analysis. A problem must be well understood and stated in an explicit form before the project team proceeds with the rest of the analysis. The term problem is used here generically. It includes all decision situations for which an engineering economy analysis is required. Recognition of the problem is normally stimulated by internal or external organizational needs or requirements. An operating problem within a company or a customer expectation about a product or service are examples. Once the problem is recognized, its formulation should be viewed from a systems perspective. That is, The boundary or extent of the situation needs to be carefully defined, thus establishing the elements of the problem and what constitutes its environment. Evaluation of the problem includes refinement of the needs and requirements, and information from the evaluation phase may change the original formulation of the problem. In fact, redefining the problem until a consensus is reached may be the most important part of the problem-solving process. Development of alternatives. The two primary actions in step 2 of the procedure are searching for potential alternatives and screening them to select a smaller group of feasible alternatives for detailed analysis. The term feasible here means that each alternative selected for further analysis is judged based on preliminary evaluation to meet or exceed the requirements established for the situation. Searching for superior alternatives. In the discussion of Principle 1, creativity and resourcefulness were emphasized as being absolutely essential to the development of potential alternatives. The difference between good alternatives and great alternatives depends largely on an individual's or group's problem-solving efficiency. Such efficiency can be increased in the following ways. Concentrate on redefining one problem at a time in step 1. Develop many redefinitions for the problem. Avoid making judgments as new problem definitions are created. Attempt to redefine a problem in terms that are dramatically different from the original step 1 problem definition. Make sure that the true problem is well researched and understood. In searching for superior alternatives or identifying the true problem, several limitations invariably exist, including lack of time and money, preconceptions of what will and what will not work, and lack of knowledge. Consequently, the engineer or project team will be working with less than perfect problem solutions in the practice of engineering. Okay, so we have example 1, defining the problem and developing alternatives. The management team of a small furniture manufacturing company is under pressure to increase profitability to get a much-needed loan from the bank to purchase a more modern pattern cutting machine. One proposed solution is to sell waste wood chips and shavings to a local charcoal manufacturer instead of using them to fuel space heaters for the company's office and factory areas. Letter A. Define the company's problem. Next, reformulate the problem in a variety of creative ways. And B. Develop at least one potential alternative for your reformulated problems in Part A. Okay, here is the solution. In letter A, the company's problem appears to be that revenues are not sufficiently covering costs. Several reformulations can be posed. First is the problem is to increase revenues while reducing costs. Second, the problem is to maintain revenues while reducing costs. Third, the problem is an accounting system that provides distorted cost information. And number 4, the problem is that the new machine is really not needed. Hence, there is no need for a bank loan. On letter B, based only on reformulation 1, an alternative is to sell wood chips and shavings as long as increased revenue exceeds extra expenses that may be required to heat the buildings. Another alternative is to discontinue the manufacture of specialty items and concentrate on standardized high-volume products. Yet another alternative is to pool purchasing, accounting, engineering, and other white-collar support services with other small firms in the area by contracting with a local company involved in providing these services. Developing investment alternatives. It takes money to make money, as the old saying goes. Did you know that in the United States, the average firm spends over $250,000 in capital on each of its employees? So, to make money, each firm must invest capital to support its important human resources. But in what else should the individual firm invest? There are usually hundreds of opportunities for a company to make money. Engineers are at the very heart of creating value for a firm by turning innovative and creative ideas into new, re-engineered commercial products and services. Most of these ideas required investment of money, and only a few of all feasible ideas can be developed due to lack of time, knowledge, or resources. Consequently, most investment alternatives created by good engineering ideas are drawn from a larger population of equally good problem solutions. But how can this larger set of equally good solutions be tapped into? Interestingly, studies have concluded that designers and problem solvers tend to pursue a few ideas that involve patching and repairing of an old idea. Truly new ideas are often excluded from consideration. This section outlines two approaches that have found wide acceptance in industry for developing sound investment alternatives by removing some of the barriers to creative thinking. That is first, classical brainstorming, and second, the nominal group technique. Classical brainstorming. Classical brainstorming is the most well-known and often used technique for idea generation. It is based on the fundamental principles of deferment of judgment and that quantity breeds quality. There are four rules for successful brainstorming. First is criticism is ruled out. Second, freewheeling is welcome. Third, quantity is wanted. And four, combination and improvement are sought. A. F. Osborne lays out a detailed procedure for successful brainstorming. A classical brainstorming session has the following basic steps. First is preparation. The participants are selected and a preliminary statement of the problem is circulated. Second is brainstorming. A warm-up session with simple unrelated problems is conducted. The relevant problem and the four rules of brainstorming are presented, and ideas are generated and recorded using checklists and other techniques if necessary. Third is evaluation. The ideas are evaluated relative to the problem. Generally, a brainstorming group should consist of 4 to 7 people, although some suggest larger groups. Nominal group technique. The NGT or nominal group technique developed by Andre P. Delbecq and Andrew H. Van Deven involves a structured group meeting designed to incorporate individual ideas and judgment into a group consensus. By correctly applying the NGT, it is possible for groups of people, preferably 5 to 10, to generate investment alternatives or other ideas for improving the competitiveness of the firm. Indeed, the technique can be used to obtain group thinking on a wide range of topics. For example, a question that might be given to the group is, What are the most important problems or opportunities of improvement of the technique, when properly applied, draws on the creativity of the individual participants while reducing two undesirable effects of most group meetings: the dominance of one or more participants and the suppression of conflicting ideas. The basic format of an NGT session is as follows. First, individual silent generation of ideas, then individual round-robin feedback and recording of ideas. Third, group clarification of each idea. Fourth, individual voting and ranking to prioritize ideas. Fifth, discussion of group consensus results. Development of prospective outcomes. Step 3 of the engineering economic analysis procedure incorporates principles 2, 3, and 4 and uses the basic cash flow approach employed in engineering economy. A cash flow occurs when money is transferred from one organization or individual to another. Thus, a cash flow represents the economic effects of an alternative in terms of money spent or received. Consider the concept of an organization having only one window to its external environment through which all monetary transactions occur: receipts of revenues and payments to suppliers, creditors, and employees. The key to developing the related cash flows for an alternative is estimating what would happen to the revenues and costs as seen at this window if the particular alternative were implemented. The net cash flow for an alternative is the difference between all cash inflows and cash outflows during each time period. In addition to economic aspects of decision-making, non-monetary factors often play a significant role in the final recommendation. Examples of objectives other than profit maximization or cost minimization that can be important to an organization include the following. First, meeting or exceeding customer expectations. Next is safety to employees and to the public. Another is improving employee satisfaction, maintaining production flexibility to meet changing demands, meeting or exceeding all environmental requirements, and achieving good public relations to being an exemplary member of the community. Selection of a decision criterion. The selection of a decision criterion incorporates Principle 5. The decision maker will normally select the alternative that will best serve the long-term interest of the owners and the organization. It is also true that the economic decision criterion should reflect a consistent and proper viewpoint to be maintained throughout an engineering economy study. Analysis and comparison of alternatives. Analysis of the economic aspects of an engineering problem is largely based on cash flow estimates for the feasible alternatives selected for detailed study. A substantial effort is normally required to obtain reasonably accurate forecasts for cash flows and other factors in view of, for example, inflationary pressures, exchange rate movements, and regulatory mandates that often occur. Clearly, the consideration of the future uncertainties is an essential part of an engineering economy study. When cash flow and other required estimates are eventually determined, alternatives can be compared based on their differences as called for by Principle 2. Usually, these differences will be quantified in terms of monetary units such as dollars. Selection of the preferred alternative. When the first 5 steps of the engineering economic analysis procedure have been done properly, the preferred alternative is simply a result of the total effort. Thus, the soundness of the technical, economic modeling and analysis techniques dictates the quality of the results obtained from the recommended course of action. Step 6 is included in Activity 5 of the engineering design process when done as part of the design effort. Performance monitoring and post-evaluation of results. This final step implements Principle 7 and is accomplished during and after the time that the results achieved from the selected alternative are collected. Monitoring project performance during its operational phase improves the achievement of related goals and objectives and reduces the variability in desired results. Step 7 is also the follow-up step to a previous analysis, comparing actual results achieved with the previously estimated outcomes. The aim is to learn how to do better analysis, and the feedback from post-implementation evaluation is important to the continuing improvement of operations in any organization. Unfortunately, like step 1, this final step is often not done consistently or well in engineering practice. Therefore, it needs particular attention to ensure feedback for use in ongoing subsequent studies. Here we have another example. Application of the engineering economic analysis procedure. A friend of yours bought a small apartment building for $100,000 in a college town. She spent $10,000 on her own money for the building and obtained a mortgage from a local bank for the remaining $90,000. The annual mortgage payment to the bank is $10,500. Your friend also expects that annual maintenance on the building and grounds will be $15,000. There are 4 apartments, 2 bedrooms each in the building that can each be rented for $360 per month. Refer to the 7-step procedure to answer these questions. Letter A. Does your friend have a problem? If so, what is it? Letter B. What are her alternatives? Identify at least 3. Letter C. Estimate the economic consequences and other required data of the alternatives in Part B. Letter D. Select a criterion for discriminating among alternatives and use it to advise your friend on which course of action to pursue. Letter E. Attempt to analyze and compare the alternatives in view of at least one criterion in addition to cost. Letter F. What should your friend do based on the information you and she have generated? Okay, so here is the solution. Letter A quick set of calculations shows that your friend does indeed have a problem. A lot more money is being spent by your friend each year. That is 10,500 plus 15,000 equals to 25,500. Than is being received. That is 4 times $360 times 12 equal to 17,280. The problem could be that the monthly rent is too low. She's losing $8,220 per year, and that is a problem. Letter B. Here are the alternatives or options that she can do. Option 1, raise the rent. Will the market bear an increase? Option 2, lower maintenance expenses, but not so far as to cause safety problems. Option 3, sell the apartment building. But what about a loss? And option 4, abandon the building, which is bad for your friend's reputation. Okay, so here is answer or solution to letter C. Option 1, raise total monthly rent to 1,450 plus R dollars for the 4 apartments to cover monthly expenses of 2,150. Note that the minimum increase in rent would be 2,125 minus 1,440 divided by 4, which is equal to $171.25 per apartment per month. That is almost 50% increase. For option 2, lower monthly expenses to 2,125 minus C dollars, so that these expenses are covered by monthly revenue of 1,440 per month. This would have to be accomplished primarily by lowering the maintenance cost. Monthly maintenance expenses would have to be reduced to 1,440 minus 10,500 divided by 12 equal to $565. This represents more than a 50% decrease in the maintenance expenses. For option 3, try to sell the apartment building for X dollars, which recovers the original $10,000 investment and recovers $685 per month loss on the venture during the time it is owned. For option 3, try to sell the apartment building for X dollars, which recovers the original $10,000 investment and recovers the $685 per month loss on the venture during the time it was owned. For option 4, walk away from the venture and kiss your investment goodbye. The bank would likely assume possession through foreclosure and may try to collect fees from your friend. This option would also be very bad for your friend's credit rating. For solution to letter D, one criterion could be to minimize the expected loss of money. In this case, you might advise your friend to pursue option 1 or 3. Solution to letter E, for example, let's use credit worthiness as an additional criterion. Option 4 is immediately ruled out. Exercising option 3 could also harm your friend's credit rating. Thus, options 1 and 2 may be her only realistic and acceptable alternatives. For letter F, your friend should probably do a market analysis of comparable housing in the area to see if the rent could be raised. Maybe a fresh coat of paint and new carpeting would make the apartments more appealing to prospective renters. If so, the rent can probably be raised while keeping 100% occupancy of the 4 apartments. Okay, so that ends our lecture. Thank you for watching lecture 2.
Magbabaksakan dito in 5, 4, 3, 2.
1, 2, 3.
DJ Joanna, sabay